So the last part of solving one of these problems is we have to figure out what our coefficients actually are. So we've got these two relationships. I'm going to write them in terms of either the highest number, so C2 is equal to C0 over 2, or I'm going to rewrite it using k's because that is a way to avoid some confusion later. So ck plus 2 is going to be ck plus ck minus 1 over k plus 2 times k plus 1. If it doesn't bother you to have n mean multiple things over the course of a problem, then don't worry about that step. But I'm just doing it to minimize potential sources of confusion in what is a very long problem. Okay, so now we just sort of go down the line and find out what our coefficients are. So for n equals 0, we don't know anything about C0. We know that C2 is going to depend on it, but that doesn't tell us anything quite yet. And we're going to have the same outcome for n equals 1. C1 is C1. For n equals 2 is where things will start to change. Then we're going to be able to say n2 is C0 over 2. Oops, sorry, that's C2 is C0 over 2. I put all that on one line because it's sort of like our initialization process. After this, we're always using the second relationship. So usually the first like 3 or 4 coefficients use assuming relationship or assuming unknown constants in the first relationship, and then after that you move on to always the second one. So from n equals 3, if we want to have n equals 3, we want to have k plus 2 equals 3, means k equals 1. So we'll have C3 is equal to C1 plus C1 minus 1 is 0 over 1 plus 2 is 3 times 2. N equals 4 is going to give us k equals 2. So C4 will be C2 plus C2 minus 1 is 1 over 2 plus 2 is 4 times 3. And then my two unknowns are C1 and C0, so I'd better go ahead and replace the C2 with what I already know, which is that it's C0 over 2. So that's going to give me C0 over 2 over 4 times 3 plus C1 over 4 times 3. So that's C0 over 4 times 3 times 2 plus C1 over 4 times 3. If you want to separate out these ones too, you can at this stage. The reason is because C0 and C1 are going to be like the two numbers that always come back. So keeping them separate can keep things cleaner. Sorry, people are very excited about cat videos at the moment, so my phone is just going off. K equals 3 is how we're going to get C5. That's going to be C3 plus C2 over 5 times 4. Maybe once you do a few of these, you don't even have to think about the original formula, you just think back to what you did last time and add up the numbers. But we want to make sure to replace C3 with what we already know. So that's going to be C1 over, I'll show this to you once the way it is, and then we can just do it automatically from now on. So C3 was C1 over 3 times 2 plus C0 over 3 times 2. And then C2 was C0 over 3 times 2. All of that over 5 times 4. So we can go ahead and say that C1 over 5 times 4 times 3 times 2 plus 2 C0s over 5 times 4 times 3 times 2. So those 2's will cancel out. Like that. N equals 6. That's going to come from k equals 4. C6 is C4 plus C3 over 6 times 5. C4 we know from this, so I'm just going to add an extra 6 times 5 to that. So I'm going to have C0 over 6 times 5 times 4 times 3 times 2 plus C1 over 6 times 5 times 4 times 3 times 2. Oops, don't go down to 2. And then C3 I know is this, so I'll go ahead and just write those with the extra 6 times 5. So C1 over 6 times 5 times 3 times 2 plus C0 over 6 times 5 times 3 times 2. And we could even combine those terms, I guess. 1 over 6 times 5 times 4 times 3 times 2 plus 1 over 6 times 5 times 3 times 2 C0 plus 1 over 6 times 5 times 4 times 3 plus 1 over 6 times 5 times 3 times 2 times C1. Let's go ahead and I guess do one more. Maybe we can start to see the formula here, but you know, couldn't hurt to do an extra one, I guess. So n equals 7, that's k equals 5, that's C7 is C5 plus C4 over 7 times 6. So C5 was that thing. So I'm going to have, actually, you know what? I'm going to bring back that too. C1 over 7 times 6 times 5 times 4 times 3 times 2 is 7 factorial. Plus 2C0 over 7 times 6 times 5 times 4 times 3 times 2 was also 7 factorial. That canceling out those 2's made my life harder when I was writing out these terms because I couldn't use my factorial notation so easily. So I won't do that anymore. And then C4 is C0 over 4 times 3 times 2. Let's say that's 2C1 over 4 times 3 times 2. So that's going to give me C5 over 7 times 6 times 5 times, 7 times 6 times 4 factorial. Let's go ahead and do that. Plus, C0. Plus 2C1 over 7 times 6 times 4 factorial. Just skipping a 5. You could go ahead and combine those things if you wanted to, but I mean, hopefully we're seeing the pattern now that you kind of have a regular factorial term plus a factorial-ish term that's skipping like the 5 here, or it skipped the 4 before. Whatever k value we're currently at is what it's skipping. Times C1, same pattern for C0. 2 over 7 factorial plus 1 over 7 times 6, skip the 5, 4 factorial, C0. So that's what's happening, even though it's kind of hard to see what that would actually mean. So let's just write out the solution real quick. The fundamental solutions are going to be y1 equal to everything attached to C1 and y2 equal to everything attached to C2. What that's going to be is that y1 will be like x plus x cubed over 3 times 2 plus x to the 4th over 4 times 3, so on and so forth. And y2 will be like 1 plus x squared over 2 plus x cubed over 3 times 2 plus x to the 4th over 4 times 3 times 2, so on and so forth. It could be actually like a 2x to the 4th over 4 times 3 times too if you wanted. And y equal to c1 y1 plus c2 y2. I am sorry to be cutting that off real short, but we're at like the length of time that we would have in a normal class. So I'm going to stop here and give you your wrap-up video. If making this connection between this representation right here and writing it in a complete form over here was unclear, that's okay. We're going to practice that even more next week. For now, if you can get like to this stage, that's going to be an accomplishment. So don't worry.